See, uh, this is a optimization technique, especially specifically when you have unimodal function. Unimodal function means a function in one variable. Okay. Suppose you are going to find minima or maxima in one variable, then you can use this method. And this method is used when you are not going to use derivation. Because in some cases you use derivation, right? Sometimes you need derivative of function. In this golden search method, you will not use derivation. Understood? Yes. But this method, see, uh, suppose you have a function, and interval is a to b, and this function is unimodal function. Unimodal function means a function in one variable. When a function in one variable, it has only one minima or one maximum point, right? Yes. So in golden search method, what do you use? Yes, you can say also this, right? So it is used for one dimensional. One dimensional means when it has only one minima or one maxima, and when you do not use derivation. Understood? For example, x square plus 4, x square plus 3, right? So you can use here golden search method. See, one thing you must know, this is called golden ratio. Golden ratio is what? 1.618. This is constant value. And how you got this? This is nothing but root 5 minus 1 by 2. Okay? Yes. Root 5 plus 1. When you do minus, you will get 0.618. Okay. This is called golden ratio. Golden ratio is represented by 5 and its value is 1.618. Understood? And this is nothing but a plus b divided by a is equal to a upon b. Its value is always 1.61. For example, when you see Fibonacci number, what is Fibonacci number? Yes, this is Fibonacci sequence, right? And common expression is right. So in this type of problem, you can use golden search method. Yes, and this is called golden ratio. Understood? Yes. Suppose A is x and B is 1, right? And x upon 1. When you solve this, you will get an equation x square is equal to x plus 1, right? X square minus x minus 1. This is quadratic equation. When you solve quadratic equation, you will get. Understood? And this is nothing. When you take positive sign, you will get 1.618. When you take negative sign, you will get 0.618. Understood? Okay. What? Yes, you will take positive value. Why you are taking positive value? Why 1.618 matters? See, when you take 3 by 2, you will get what? 1.5. Do 5 by 3. What do you will get? Check. 5 by 3 is what? 1.667. Take 8 by 5. 1.6 perfect. 13 by 8. 625. When you take next term is what? 21, right? Na? So when you see the next term divided by its previous term, approximately always you will get 1.618. Okay, and this is called golden ratio. Now you understood? Yes. Note this, then I tell you how to use this. Always take positive sign. Yes, yes, I am recording. Okay, noted? Yes. See, now I write algorithm. See, again, golden search method used only when this is unimodal function, right? Unimodal function means only one maxima and one minima exist. And when you do not want to use derivation, right? Suppose you want to find minima and maxima of this function using golden search method in the interval 0 to 5, right? Yes. So first, uh, first find golden ratio constant. What is golden ratio constant? There are two constant. One is positive, 1.618, and when you take negative, you will get what? 0.618, right? So what is golden ratio constant? Yes. So suppose you choose second one, right? I will tell you further when to use which 5.1 or 5.2. So let's suppose you choose what? Second one, and this is R. Ratio, it is denoted by ratio R. Okay. 1618. What is 1 minus R? So these two value frequently uses. Okay. Okay. Interval is what? This is A and this is B. Understood? First find L. L is what? Limit. Limit is from B to B A. 5 minus 0. That is 5. Understood? Yes. First we find interior point. This is called length. Length mean you go from 0 to 5 means 5 length. Length of 5. So first we find interior point. Let's suppose interior point is x1 and x2. Okay. So from 0 to 5 in this range, this is x1 and this is x2. What is x1? A plus, this is formula 0.382L. Understood? And this is A plus 0.618L. Understood? Okay. What is L? And what is A? Yes, what is the value of this? 1.590. So find the value of f at x1. What? 1.590. Put here 1.590. Tell me what is the value. And also find f x2. First calculate this. 3.090. Okay. And also tell me the value of this. Put here 1.590. 1.1681. Okay. And for this 2.1881. Okay. Which one is greater? Fx2, right? Yes. So, see, always check these two cases. If fx1 is less than fx2, then minima lies on right side because this is minimum value. Okay. Because x2 is on always right side and x1 is on left side. You can see here, this is 0, this is 5, and this is 1.59. Let's suppose 591, and this is 3.09. Which one is greater? This is greater, and which is on right side. That's why the minima lies on right side. If this condition satisfied, but in this case, fx2 is greater, right? So what you can conclude? Minima lies on left side, right? Then minima lies on left side. Understood? Yes. So in this case, this is the for checking purpose. Okay. Okay. Now you can see in this case, since fx1 is less than fx2, minimum lies in left interval, right? Yes. Understood? See, if first condition satisfied, then your new interval becomes a comma b, it change into x1 comma b, right? And a, if second condition satisfied, then interval becomes a comma x2. Up to here, understood, right? Because x2 fx2 is greater, fx2 is greater means you will take which part? Discard right side, because you will not go from x2 to 5, because your target is what? Finding minimum value, right? Yes. Now this interval change with what? This is first iteration. Understood? Yes. Since fx1 is less than fx2, then discard right side. Right side means what? You need not to take x2 to 5. Then what will you take? 0. Yes, 0 to x2. A to x2. I write here. Right? A to x2 means now you have to check in this interval 0 to 3.09. Understood? Yes. In second iteration, can we move? Yes, you can write some important point. This is important. Then I tell you second iteration. Okay. Now again take r is equal to what? 0.618, right? 1 minus r is this. What is length? Length will also change because this is 0 and this is 3.09. Right? L becomes what? X2 minus 8, right? 3.09 minus 0, which is equal to 3.09. Understood? So here you will put 3.09 and here also 3.09. Understood? Find the value. Okay, what is the value of this? This is also updated. Tell me 3.09 into 0.382. You can draw here for your easiness. Write here 0 and this is what? 3.0. No, you discard right side, na? That's why in second iteration you can draw this from 0 to 3.9. So I think you are getting 1.18, right? And 1.91. So whatever you are getting, it is greater than 0 and less than 3.09. Why? Because these are interior points. Understood? And the value at 1.18 is when you put here 1.6724. And what is the value at 1.91? Tell me. 1.0081. And right here, this is x1 and this is x2. X1 is what? 1.18, 1.91, which are integer parts, right? Now tell me who is greater? 1.67. Value, not point. Fx1 is greater than fx2, right? Other side. So you can say minima lies on right side. Understood, na? So new interval will be x1 to b, right? This part. Because it lies on right side, so left side will be discarded. Understood? Yes. Here I discard left side. New interval will be what? 1.18 to 3.09. Understood? So in third iteration, you will take from 1.18 to 3.09 and repeat this procedure. Understood? Uh, Up to here you understood? See, see, at 1.18 you got 1.67 and 1.19, 1. Who is greater? Yes, 1.67. So fx1 is greater. If fx1 is greater means this is greater. If this is greater, then discard this one. If this was greater, then discard this one. Understood? Because you are going to find minimum value, right? So you discard left side. Left side means from 0 to 1.8 is not needed. Yes, minima lies on right side. Understood? So your new interval will be from 1.18 to 3.09. Understood? Yes. In third iteration, repeat the same procedure. In third iteration, your interval will be yes. R is same. L will be what? Understood? Yes. Now you can ask me, sir, how many iteration we can do? So you do until you get this b minus e less than epsilon. What is epsilon? Epsilon is called tolerance value. Sometime in the question it is already given the value of epsilon. Epsilon is what? Let's suppose epsilon is 0.0001. So when you subtract this b minus a, if you are getting this 1.0001, then you can stop there. Understood? Otherwise, repeat the iteration until this is satisfied. Okay? So I think you understand the concept. We will do one more question with fresh and with all steps, right? Yes. Only remember these 2 points. If fx1 is less than fx2, keep left interval. That's it. And discard right interval. Understood? If fx1 greater than fx2, keep right interval. And discard left interval. This is for finding minima. Very important. Okay. For finding maximum value, just do opposite. For maxima, keep right interval and keep left interval. Okay. Understood? Now we will do one question from your notes. In third iteration, actually epsilon was not given. So we will do that question in which epsilon is given. This is x1 and this is x2. X1 and x2 are interior points. Okay. Yes. And what is the formula of x1? A plus 1 minus r into L, right? Okay. Yes. X1, x2 was not given. We find there, right? This is RL. What is R? R is nothing but a ratio constant, and this is equal to 0.618. Okay. And what is L? B minus A, length of interval. This is the rule of golden search method. And do iteration until you get A minus B is less than epsilon. Epsilon is what? Tolerance value. Unlimited value. Or you can significance of error. Okay. Okay. See this question from your notes. Read the question. Perform only 3 iterations, right? If already iteration is given, then it is not needed. But no problem, sometimes both are given. Okay. And which method you will use? For 54 by x. And what is the interval? Not included. Okay. And we have to perform only 3 iterations. Understood? Yes. Let's see. So what will you do? Tell me. First, draw a line. This is 0 and this is 5. First, we find interior point x1 and x2. Okay. So before finding interior point, first find length of interval, which is 5. What is r? Right? What is 1 minus r? This is not. Okay. Yes. This is what? 1 minus r into r. A is what? 0 plus 1 minus L is 5. Tell me the value of this. And x2 is? Yes. Tell me the value of this and this also. You can write your first iteration. What is the value of this? Okay, and now at 1.19 each. Okay. 31.90, right? Three point zero nine. हेलो आवाज आ रही कैन यू हियर मी हेलो चला गया ना हेलो सर्वर निकलवाई की हेलो कैन यू हियर मी यस 1 minute screen visible okay 1 minute now see what is the value at 1.91 3.0 I am getting 31.92 this is 54 yes yes 31.9 and what is the value at 3.09 right 27 point now you can see fx1 is greater than fx2 so this is minimum value right minimum value lies from yes so we will keep right side right yes right side means what not x2 5 left side discarded understood yes so since right? So we will discard left side. Length is 0 to 5 or 0 to 1? Okay. Here x1 is greater than x2. Okay. So what do? You will keep x1 x. No. X1 is greater. So you discard this part. You will take this part. Okay. X1. X1 means 2, 5. Right? First iteration done. Now you will do second iteration. Understood? What is L? 3.09. This is length of interval. What is R? R is same. What is x1? A plus 1 minus R into L. Where A is what? 1.91. 1 minus 0.618 into L is, which is equal to, and this is RL. Tell me the value of this and also its corresponding value at x1. ऍडमिशन काल करणार होत ना पप्पा काय बोलले तुम्ही बिझी बरोबर आहे सर पण तुझे सर ना मेरा बोला ऑनलाइन करा थोड़ा 2 मिनट हो जाए मग काय सर फोटो पाहिजे सर अजून उचलून नाही 3.0903, right? So you can write approximately 3.091. Okay. Okay, and this 3.819. So approximately you can write 3.82. Okay. Now the corresponding value at each point is what? So here again fx1 is less than fx2, right? So in yes, in second iteration right here, this is A and this is B. When you draw this, always try to draw this so that you can discard easily, right? So x1 is what? 3.09 and 3.82. Now you can see fx2 is greater. This is greater. So you will discard this part, right? Yes. So right only discard discard right side. Right side. New interval becomes when you discard from this to this, right? Understood? So new interval becomes 1.91 to 3.82. In third iteration, draw this. Okay. Find L. L is what? 1.9. Yes. 1.91, right? And x1 is A plus 1 minus R into L. Right. Find also fx in A. Two 2.64, right? 3.64. This 3.82 you are getting. No, 3.8 to the extreme value. Check again. 1.9. 5? This is yes, because L is also changed. 639 you can write approximately 0.64. Okay. Now I am solving this part. Find the value of f at x1. Every time L will change. Okay. In each iteration. 3.09. Okay. 3.09. Okay. 2.64. 27. Right? Which one is greater? Still fx1 is greater. You can check also. So here you are getting fx1 is greater, right? But greater per you cannot take. That's why you will take, right? So new interval becomes x1. X1 is what? 2.64 to 3.82. It means your minimum value lies in this interval, but you are asked to find only up to 3 iteration. Then no need to going further, right? Yes. So your minimum value lies at interval this. Understood? Yes. And what will be the minimum value? It is 2.4742. Oh, sorry, 27.42, 27.02. So your value lies between this to this interval. Okay. No, 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 no. Find what is the value at F 2.64. It is 27.42, right? And what is the value at 3.82? No, no, no. 3.82. In previous iteration you have done. He 28.72. Right? So your minimum value lies between this to this. Understood? And what why you stop here? Because a minus b less than epsilon. What is epsilon? It is given in the question 10 minus. And what is a here? Sorry, b minus. B minus a. What is b? 3.82 minus 2.6. Let's check. 1.18. But this is false. Right. But in the question it is said that find only a three iteration. Okay. So we will stop here. Okay. Yes. Understood up to here? Okay. So you can see here. I show you. See. So minimum value lies here. Series. So at which interval your minimum value will exist? 2.62. But still you have not find the actual minimum value. You find in golden search method, you will find an interval in which interval it lies minimum. Understood? You cannot find perfect. It's satisfied? No, no, no. But you stop here. Understood? Okay. See this. In first iteration, left side was discard. In second iteration, right side was discard. Again, in third iteration, left was discard. And in the last, you got this. Understood? Can you try this question? Do three iteration. Bracket the minimum is find the minimum for this. Okay. So discard that part which has greater value. Understood? So do this question.